Hello everyone, welcome to Ekeeda platform, and this is Jangid here, your electrical faculty, and in this video I'm going to talk about the numerical number 8 AC side voltage. So let's talk about one by one what is actually written in this numerical. So we will talk about some of the important points. So the question is saying that specifying that the bipolar DC line, it means it will have the two transmission HVDC links. Okay guys, now plus minus 100 kilovolt, and these are actually maintained at the 100 kilovolt and is delivering what? They are delivering the power, and they are delivering the power 100 megawatt. 100 megawatt, it means it is 100 into 10 raised to power plus 6, and on that is all on the DC side. Okay guys, so the bipolar DC line, which is maintained at the 100 kilovolt, which is delivering the 100 megawatt of the power, and all on the DC side. Now the power factor on the AC side of the line is 0.9. Now estimate the AC side voltage. Okay, we have to find the AC side voltage, which is actually generally we are taking the three-phase system. Okay, and the corresponding current ratio, whatever will be the current ratio in that side, we have to find. Now assume the insulations levels are all the same. As so the conversion, we have seen the same conductor, same thing is happening between the AC to DC or DC to AC. So if we are assuming that the insulation levels are same, then we can numerically convert them, and that will be easier to do. Now we will go for the solution. So how we have to solve if these fundamentals? So firstly you have to write in the given, whatever the given, the voltage is given, bipolar is given, power is given, the 100 megawatt. Okay, so likewise you have given the so many things. You have to write firstly, then you have to go for the solution and concentrate on what you have to find, that is estimate AC side voltage. If you have to find the AC side voltage, then firstly collect the data for that you can easily find that. Now we will talk about. It is written as this is the important, that since the insulation level, if I talk about the AC and the DC are going to be the same, okay, on the converter side can be related as this. If the insulation levels, this is only when the insulation levels are the same. So AC side line voltage, that is a VSL, is on the converter side can be written in this form, where the VD is you know very well, that is a DC side voltage. So it is going to be the VSL upon root 3, root 2, that is the peak value we need, and in is equal to VD. As you have to find the VSL, so just put the rearrangement and just calculate the value of that. So I can say the AC line to line voltage on the converter side of the transformer is going to be VSL. Okay, that is the VSL is equal to 100 into root 1.5. That is when you are going to take the VSL, then this will be, that is the VSL is equal to the VD, and it is going to be, the VD is here, and it is going to be 3 by 2. That's why it is written root 1.5. Now just you have to calculate the root value inside that it is having the 1.5. Just calculate and put the values here, and after the calculation you are going to get 122.5 kilovolt. Now what you have to do, you just have to put, now you have to use the IS, that is the AC current, that is you can say the AC source current we generally take. So what you are going to take, that the formula you are very much aware of, that is a power upon root 3 V line voltage and into the cos phi, and that the simply is, it is written here. Okay, so what it is written, let's talk about that. The power which we are actually talking, that is 100 megawatt, which is written here. So you just have to put the 100 megawatt value here. So that will be the 100 into 10 raised to power 6. It will be divided as root 3 into 122.5 into 10 raised to power 3. So likewise it is going to be here, and after the calculation you are going to get 523.6 ampere. Okay, now so this is all about the AC line current. Now we will talk about the DC current. What is actually the DC current? ID value, if I talk about the ID value, ID is going to be this one. Okay, and that is ID is equal to 10 raised to power 9 upon 2 into 10 raised to power 5. So this is the value we have to know about that, and calculate by it is equal to 500 ampere it is going to be. So this is all about the DC current, that is the ID. Okay, now look at the some of the points which I have included for you. That is the current ratio factor. The current ratio factor, which the corresponding current ratio it is talking about, that is the current ratio factor, that is a Kc. That is going to be root 3. Okay, this is the formula, root 3 Is upon Id into cos phi. That is actually, please remember this. This is the current ratio factor, that is a Kc. You have to just put the values. Root 3, just put, you have put the root 3 value. Is, what is the value of Is? You have the Is value, that is you have found from here, and after the calculations you are going to get here. Okay, and then you have found the 523.6, so just put the value 523.6 here. Now what is the ID? ID you have found 10 raised to power 9 upon 2 into 10 raised to power 5 equal to 500 ampere. Then this is just put the values, and at the last you have to multiply the cos phi, that is a power factor, which is actually the 0.9. When you are going to calculate this, you are definitely going to get the 1.813, that is the current ratio factor. So I hope you have understood all the points which are related with the numerical number 8, that is the AC side voltage. Thank you so much.